Welcome to qnawire.
So now we're going to work on problem 57 from chapter 5. In this problem, they ask us for 4 different molecules to determine the electronic and molecular geometries, as well as the idealized bond angle, and also to determine if the bond angle in the molecule would be ideal. So in part A, we're given PF3, phosphorus trifluoride. And so phosphorus, this compound here will have 26 electrons, 5 from phosphorus and 21 from the fluorine atoms. So we can draw phosphorus with 3 fluorine atoms surrounding it. We can assign 18 electrons as lone pairs to the fluorine atoms. So counting the bonds, that leaves us with, we've used up 24 electrons, so we add 2 more as a lone pair to the phosphorus atom, the center atom. So now, based on this structure here, we can determine electronic geometry, molecular geometry, angle, idealized angle, and whether it's ideal. So for electronic geometry, we have 4 electron groups surrounding the center atoms. So for 4 electron groups, our electron geometry is tetrahedral. So if we had 4 bonds for bonded atoms, the molecular geometry would be tetrahedral as well. However, the molecular geometry doesn't see the lone pair. So if we take out one electron group from the tetrahedral structure, what we get is trigonal pyramidal, a triangular pyramid. And for tetrahedral molecules, the idealized angle is 109.5 degrees. However, that's for 4 bonded atoms. When we have a lone pair, it has higher electron density, and so it takes up more space, which pushes the other atoms closer together. So this angle in this molecule would not be ideal. In fact, it would be less than 109.5. So in part B, we're given sulfur Br2, bromine 2. We have 14 electrons from bromine, 6 from sulfur, for a total of 20 electrons. So we have sulfur as our center atom with 2 bromine atoms attached. That uses up 4 electrons. We add 12 electrons as lone pairs to the 2 bromine atoms. So we've used up 4 and 12, so we have 4 electrons left to assign. We assign them to the center atom, sulfur. And so this is the correct structure based on the absence of formal charge. So we can draw the electronic geometry, the molecular geometry, again, the angle, and whether it will be ideal. So once again, we have 4 electron groups, 2 bromine atoms and 2 lone pairs. So our geometry for the electronic geometry will once again be tetrahedral. This time, however, we've removed 2 atoms. There's 2 electron groups which we don't see in the molecular geometry. So instead of being trigonal pyramidal when we removed 1 group, it will be bent, similar to water. So again, the idealized angle for tetrahedral compounds is 109.5 degrees. However, because of these lone pairs, especially now that we have 2 lone pairs, we're pushing these bromine atoms closer together, and so it will not be the idealized bond angle. In part C, we're given CHCl3, also known as chloroform. We have 21 electrons from chlorine, 4 from carbon, 1 from hydrogen, for a total of 26 electrons. We have a carbon atom surrounded by 3 chlorine and 1 hydrogen atoms. This takes up 4 electrons, 4 bonds, 8 electrons. So we have 18 left to assign, and we can assign 6 each, and as 3 lone pairs to each chlorine atom, which will take up all our electrons. And every atom has an octet or duet for hydrogen and no formal charge. So when we look at the electronic geometry, molecular geometry, the angle, and whether it's ideal again. So again, we have 4 electron groups. So our electronic geometry is tetrahedral. However, this time we also we have 4 bonded atoms, so our molecular geometry is also tetrahedral. The bond angle, ideal bond angle for tetrahedral compounds is 109.5 degrees. And even though we have some slightly different electronegativity between the chlorine and the hydrogen, we do have 4 bonded atoms, and the difference between chlorine and hydrogen is not as great as between the lone pairs and any other bonded atoms. So this bond angle will be very close to ideal. In part D, we get carbon disulfide, CS2. We have 4 electrons from carbon, 12 from sulfur, so we have 16 electrons total. We draw carbon as our center atom, attach it to 2 sulfur atoms, which takes up 4 electrons. So we have 6 left to assign, or 12 left to assign. However, we see that just from the beginning that we're going to need to use double bonds because we don't have enough electrons to assign lone pairs everywhere. So instead of adding 3 lone pairs, we're going to add a double bond and 2 lone pairs to each sulfur atom. So we've used up 16 electrons, and all our formal charges are 0. So we can move on to electronic geometry, or all the geometry that we have to specify. So here we have only 2 electron groups. So the electronic geometry is linear. Both of those are electron groups. So our molecular geometry are bonded atoms, so our molecular geometry is linear. For linear molecules, the bond angle is 180 degrees. And here, we don't have any deviation from that since there are no lone pairs. So it is an ideal bond angle.